Application of KCL, Kirchoffs current law. So Kirchoffs current law states that the algebraic sum of currents entering into the node is equal to the algebraic sum of currents leaving from the node. So in this circuit, this is the Kirchoffs current law. In this circuit, there is from here the current is entering into the node. So here we are considering this as a node point. So the algebraic sum of currents entering into the node is considering as IT, and the algebraic sum of currents leaving from the node is considering as this current is I1 and this current is I2. So entering is equal to leaving. So IT should be equal to I1 plus I2. So this is the statement. So now we are going to do practically. So before doing practically, we have to make ready with all the wires, and after that we have to do the experiment. So this is Kirchoffs current law. So for this circuit, what we need: one voltmeter, one RPS regulated power supply, one resistance, second resistance, and ammeter. Here we need 3 ammeters, but as of while doing the circuit, they will be giving only 1 ammeter. So what we have to do, we have to short circuit these connections. First we assume that there is no ammeter over here, and we have to short circuit. That means without this we have to connect the circuit. So without that, how we are going to connect? So wherever ammeter is there, what we have to do? We have to short circuit. We have to close that circuit. Okay. And here also there is ammeter. We are taking only two R1 and R2. So I am closing this ammeter path, and I am closing another ammeter path also. Okay. First we have to do this. After that only we have to give the connections. So here I need RPS regulated power supply. So I am going to take these 2 terminals or these 2 terminals. So I am going to take this point, RPS terminals, and I am going to connect RPS to here, positive to positive and negative to negative. Next I am going to connect the resistances. So here are the resistances. We are going to consider 1 kilo ohm resistor and 1.5 kilo ohm resistor. So first of all I am going to take 1 kilo ohm resistor. So as resistance is a linear element, you can connect either or way. That means there is no positive and negative. You can connect this you can interchange these terminals also. There won't be any problem because this is a linear element. Okay. Next, one more resistance we are considering, that is 1.5 kilo ohm. So here also I am taking 1.5 kilo ohm and considering it as a second resistance. So these are the connections. Okay. Now we assume that there are no ammeters over here. So everything is short circuited. Now what you have to do? You have to switch on the circuit. Switch on the circuit and put this voltmeter. What is the range of this voltmeter? 0 to 30 volts. So put this voltmeter across RPS regulated power supply. So ikkada RPS majjalo connect chesi adjust this to 10 volts. So slowly you have to adjust it to 10 volts. Here we need only putting it into constantly. Once you kept 10 volts constantly, there is no need of using this voltmeter. So take off this voltmeter, no need of using this voltmeter. Now the supply is 10 volts. Now what you have to do? We have to take the ammeter of range 0 to 200 milliamps. 0 to 200 milliamps, switch to 0 to 200 milliamps. Once the ammeter is of 0 to 200 milliamps, take these 2 terminals and see the connections. First we have to find out the current over here, IT current we have to find out. So wherever this connection is there we have short circuited. So take off these connections, take off this wire, okay, and connect ammeter across positive to positive and negative to negative. Then we got IT value. What is IT value? 18.6 milliamps. So in the tabular column, okay, this is KCL. We are considering voltage as 10 volts and R1 as 1 kilo ohm and R2 as 1.5 kilo ohm. And next, practically, what is the total current? IT current is 18.6 milliamps. Okay, after that, now I got IT value, that means I got the current over here. Then what you have to do? Take off the meter connections and replace the circuit. So take off the meter connections again and replace the circuit as it is. Now I got IT value and the circuit is in closed loop. Now I want I1 current. So I1 current means this one. So take off the wires which was connected for ammeter and put the ammeter over here and write down the current rating, that is of 11.0. So here I1, this is IT, this is I1 and this is I2. So I1 current is, we are going to find out I2 value. So for finding I2 value here already we have shorted, so we have to take out this wires where we have shorted the I2 current, and that should be replaced with this ammeter. Why we are doing like this? Because they are going to provide only one ammeter. Here we need 3 ammeters. So what is the value we are going to get? 7.4 amps. So I2 value we are going to get 7.4 amps. So if you observe carefully, 11 plus 7.4, that is 18.4, almost equal to 18.6. Why? We are getting 0.2 difference because of the tolerance present in the resistor. Resistor value tolerance will be varying. That is the reason we are getting little variation. So practically we have completed. Now theoretically if you observe, R1 value is 1 kilo ohm, R2 value is 1.5 kilo ohm and V equal to 10 volts. We have taken like this. So what I need? I need individual currents I1 and I2. For finding individual currents, first I need IT value. So IT value means V by RT. So RT means how this two resistances are in parallel. So 1 by RT equal to 1 by R1 plus 1 by R2. If you do it, RT will be R1 R2 by R1 plus R2. So R1 value is 1000, R2 value is 1500, and R1 1000 and R2 value is 1500. So RT value we got 600 ohms. So substitute this 600 ohms here. So V by RT 10 by 600. The total current what we are going to get is 0.0167 amps. After getting IT value, now I am using current division rule. What is the rule? Current division. That means if I want a branch current I1, so okay, so I1 equal to total current into opposite resistance. What is the opposite resistance value? Here we have taken 1.5 kilo ohm. So here we have taken 1.5 kilo ohm, and here we have taken 1 kilo ohm. So opposite resistance value is 1.5. So 1.5 by, that is 1500, 1.5 K, that is 1500 by 1000 plus 1500. So totally we got I1 value as 0.01 amps. Next I need I2 value. So second branch current. So second branch current, the formula is total current into opposite resistance. So for IT, opposite resistance is R1. So R1 by R1 plus R2. That is IT value is 0.0167 into R1 value is 1000 and RT total resistance is 2500. That is 1000 plus 1500. So I2 value is 6.68 milliamps. So if you observe carefully, this is I2 value, this is I1 value. If you add these two, I have to get IT value. That is IT should be approximately equal to I1 plus I2. So IT value is 0.0167 and I1 value is 0.01 plus 0.00668 amps. we got almost equal to 6, 8. So hence theoretically also we have proved, and these values should be kept over here. That is, IT value is 0.0167 and I1 value, I2 value. So I1 value is 0.01 and I2 value is 6.68 milliamps. Milli means 10 power minus 3. So hence we have proved. If you want to do further calculations, you can vary the voltage or you can vary the resistance values, and you can take again 2 or 3 iterations. That is 2 and 3 readings. Thank you. Verification of KCL and KVL, Kirchoffs Voltage Law and Kirchoffs Current Law. Here the statement states that the algebraic sum of voltages in any closed path of a given circuit is always 0. So this is the circuit KVL, Kirchoffs Voltage Law. If you observe carefully, in Kirchoffs Voltage Law the resistances are kept in series with the voltage source, and here this is the circuit. So for the first resistance R1 we are going to take 1 kilo ohm resistor, and for R2 we are going to take 1.5 kilo ohm resistor, and for voltage we are going to take 10 volts. So how to do practically? See, first of all we have to connect all the wires, we have to make it ready, and then we have to connect the circuit. So first I am using one RPS which is over here. So regulated power supply, I am taking RPS connections, and after that what are the components we are having? RPS, R1, R2 and voltmeter. So R1, this is the resistance where we are going to consider. So resistance, we are going to take the terminals of 1 kilo ohm resistor, and we are going to take the terminals, we are going to connect 1.5 kilo ohm resistor. Okay, now we are going to take 0 to 30 volts voltmeter, we are going to connect voltmeter also. If you make all the wires, all the cables like this ready, it will be very easy to connect the circuit without any confusion. So we make everything ready. Now we have to give the connection. First of all, there is a RPS, regulated power supply. So connect positive terminal to positive terminal, and next connect negative terminal to negative terminal. After that, in the circuit there is a resistance R1. So R1 we are taking 1 kilo ohm resistor here. So 1 kilo ohm resistor you have to connect at R1 and R2. R1 starting terminal, ending terminal we have connected. Now we are going to take 1.5 kilo ohm resistor as R2. So starting terminal we are connecting here, ending terminal we have to connect. You can connect in either of the ways, because resistor is a linear element, you can connect anyway. And here in this circuit we have given one more resistance added, which is not required here in the circuit. So I am short circuiting this connection such that the circuit will be having a closed loop. Now switch on the terminals. Okay, switch on the switch. Now take the voltmeter and put on the RPS terminals, and slowly vary RPS regulator to 10 volts. So here you have to get 10 volts. Up to that you have to apply 10 volts. You can take any voltage. So here I am applying 10 volts as RPS. Now I got the voltage as RPS. Now I am going to the tabular column. Here this is the tabular column, KVL, Kirchoffs Voltage Law. So what is the input voltage? What we have given? 10 volts. Okay, what is the first resistance value? 1 kilo ohm resistor. What is the second resistance value? 1.5 kilo ohm resistor. Okay, and there is theoretical values and practical values. In the practical values, what is the source voltage we have taken? Here we can see 10 volts. So we have to put 10 volts over here, and now we have to see the voltage across V1. So where is the V1? The V1 is the terminals where you have connected across R1. So take off the terminals of voltmeter, only terminals, okay, and connect it to R1 across R1. So if you connect across R1, you will see the voltage over here. Sorry, yeah. Now you are seeing the voltage of 3.9 volts. So what is the voltage we are getting here? V1 is almost 4 volts, that is 3.9 volts. Next, now take off the terminals from the R1 and put the voltmeter terminals to R2. So this is the R2, so put across R2 resistance. So what is the value we are getting here? V2 is 5.9 volts, almost 6 volts. Okay, so if we add 5.9 and 6, that means almost 4 volts, almost 6 volts, that is almost equal to 10 volts. That means the we are getting right answers. We are getting, and the circuit is proved. Why we are getting a little difference of 0.1 volt here and 0.1 volt here? Because of the tolerance present in the resistor. In the resistor we will be having tolerance. Because of the tolerance value, we are not getting the exact values. Okay, we are getting little variable values. Okay, this is how we have to do practical. And coming to the theoretical values, what is the, here I am going to do theoretical values. So what is the source voltage we have taken? Vs equal to 10 volts. And what is the resistance 1 value? 1 kilo ohm. And resistance 2, 1.5 kilo ohm. So total resistance is RT equal to R1 plus R2, that is 1000 plus 1500, that is equal to 2500 volts. So we got total resistance of 2500 volts. Now we have to apply, we have to know the voltage across R1. So V1 equal to, there is a voltage division rule, that is total voltage into same resistance, that is R1 by total resistance R1 plus R2. So what is the total voltage here? 10 volts. And what is the resistance R1? 1 kilo ohm, that is 1000 ohms, by R1 plus R2, that is 1000 plus 1500, that equal to 10,000, 10 kilo ohm by 2500 ohms. Right, then what is the total value we are getting here? 4 volts. Okay, like that. Now we are going to find out the second voltage, V2 equal to, what is the formula? Voltage division rule, Vt into same resistance. So we are taking the voltage of second resistor, so same resistance means R2. So R2 by R1 plus R2. So here also total voltage is 10 volts and R2 value is 1500 by total resistance is 2500. So how much we are going to get? 6 volts. So Vs is supposed to be equal to V1 plus V2, right? So Vs value is 10 and V1 value is 6. Sorry, V1 value is 4 volts and V2 value is 6 volts. That is 10 volts. Hence 2. So these values we have to keep here in this table. So what is Vs? 10 volts. What is V1 value? We got 4 volts. And what is the V2 value? 6 volts. Like that, if you want to repeat this cycle, you can put 12 volts you can put 15 volts, you can take another resistance values like a R1 value different, R2 value different, and you can do this continuously. This is how you have to do. Thank you very much.